So, to start with talking about topology, we need to talk about poles and loops, right? So we know what a loop is. A loop is a series of edges connected end to end, right? And when we talk about loops in topology, we're sort of going to be talking about like the border of a strip of polygons, something like this, right? Or in fact, colloquially, some people mean to say this strip here, right? The central geometry. I guess technically what they mean to say is a ring, but like saying a loop just kind of sounds intuitive, so we're just going to say that, right? So the basic idea is that if we have a loop going in one direction up our geometry, maybe it's leaning to the left, and then we have another loop that wants to go sort of to the right, like this, then we can join this in one of two ways, right? If we wanted, we could have this strip of geometry like this. Oh, I've drawn that last line here pretty poorly, like this, right? And then let's say we subdivide it a few times like this, running up the loop as we're making it. Okay. This other one naturally is going to need some geometry, so this side sort of makes sense. We could merge them like that. But then we could, if we wanted, do this. And this would be pretty dreadful, right? Because what we've done is we've made these like really long polygons here which aren't really helping us, and we also haven't actually, this is the key point, we haven't diverged the two loops at all. All we've done is made this structure here, like we've just made a grid. It's just really stretched to one side, but do you see how like this is still a grid? These two are still just a regular grid like this without actually diverging. So in order for this to diverge, we need to pick a point that's shared by both of the structures, right? So we're going to pick this one here, and from here we split off and we go this way, right? And then this would be subdivided, roughly like this kind of thing. Okay. Now, because we've chosen to split like this here, we are naturally going to get a point with greater than four edges here, because we sort of have to introduce another edge in order to split off. And if we wanted to split off again, we would introduce another edge, right? Which would be kind of crazy, but you could do it. So that's called a pole. This structure here is called a pole. Now, poles are really useful because they allow us to diverge topology and they allow us to merge topology, right? So let's say this loop continues down like this, right? And there's another loop running down here that we want this to merge into. Well, we've naturally created another pole, right? Do you see that right here? So that's what that's what poles are actually really good for, is that they allow us to divert topology and merge them back in, right? Let me just draw that in here. So the most common poles that you're going to get are like these 5-pointed poles, these sort of 5-edged poles, right? Where we have not 4, like in a standard grid, we have a 5th, right? Because instead of having a standard grid of polygons, what we've done is we've said, well, we mostly have a standard set of polygons, but then we have taken some polygons off. We've routed like another series out, right? So the 5-sided one is the most common one, but then we're also going to get some 5-edged one, but we're going to get some 3-edged ones here. I'll show you what these look like, right? That there's also a pole. And you'll see this on the edge of a cube, right? On the corners of a cube. All of the corners of a natural cube are all poles. All of them, right? Now, in the case of this structure, it's still doing the exact same thing as this is. It just looks a little bit weird. It looks a little bit different. But you can see that there's a loop that runs through like this, right? another one that runs like this, and another one that runs like this. And so you can sort of see that all three of these are diverging in different directions away from each other. This one runs 90 degrees that way, that one runs 90 degrees that way, this one runs 90 degrees that way. And so they naturally create this like pole at the center, right? So this is sort of the first key insight when we sit down and retopologize anything, that we have loops of polygons, rings of polygons, I really should be saying. We have edge loops and rings of polygons that are running along the face in some configuration, and they diverge and, you know, converge, and at each point where that happens, conceptually we are going to end up with a pole, right?